This is January 06 AS1 question 3. In projectile motion, only one force other than air resistance acts on the object which is projected. Name this force, and that force is gravity, or gravitational force. For the remainder of the question, neglect air resistance. On figure 3.1, sketch the path followed by an object following projectile motion after it is projected from a point on level ground. So they're looking for you to draw a fairly smooth trajectory there, like that. Part C, an object is projected with a velocity of 17 meters per second in a direction making an angle of 35 degrees to level ground. At a distance of 20 meters from the point of projection, there is a vertical fence. The height of the fence is such that the object just passes over it without any contact. The situation is shown below, and I'm just going to continue it there, like that. Okay, so it just passes over it without any contact. Calculate the horizontal and vertical components of the velocity of the object at the instant of projection. So you know that it's projected at an angle of 35 degrees and it has an initial velocity of 17 meters per second. So there's your two components. There's your 35 degrees and 17. So this one beside the angle here is the 17 cos 35, and this one is a 17 sine 35. So the horizontal component is this one here, 17 cos 35 degrees, and that comes out to be 13.9. The second one then, the horizontal component is, the vertical component is the 17 sine 35, and it comes out to be 9.75 meter seconds to minus 1. It then asks you to calculate the height of the fence. Now you know the horizontal distance travelled, and that horizontal distance travelled is 20 metres. And you also know the horizontal component. You know the horizontal velocity is 13.9. So you can calculate how long it takes to get to that distance. So time is distance over speed, which is 20 divided by 13.9, and that gives you 1.43 seconds. Right, so now we have to find the answer for the height of the fence. So we want to find a vertical height. But what we do know, we know that the initial velocity is the vertical component, which is at 9.75. You know the time it takes is 1.43. You know acceleration due to gravity is minus 9.81. And we are looking for a height S. And therefore S equals ut plus a half at squared, and that's equal to 9.75 times 1.43 plus a half by minus 9.81 by 1.43 squared. And that gives you an answer of 3.87 meters is the height of the fence. It then says calculate the maximum height reached by the projectile. And so we know that if we have a wee quick look at that again, it has just made it over the fence, but it goes to a greater height, a much greater height actually than that probably. It has just made it over the fence. So to calculate maximum height, we know the maximum height, we know the initial velocity, vertical velocity, so that's a vertical thing we have to find, the vertical height. So the initial velocity u is equal to 9.75. We know at maximum height that v is equal to 0. We know a is equal to minus 9.81, and we're looking for s. So if we use v squared equals u squared plus 2as, you've got 0 is equal to 9.75 squared plus 2 by minus 9.81 by s. And that's all in brackets. So S comes out to be 9.75 squared divided by 2 times 9.81. And that gives you an answer of 4.85 metres.